Okay, so in this video, we're going to cover Grignard reagents with aldehydes, ketones, esters, acyl halides, carbon dioxide, and epoxides. Now notice, we don't react Grignard reagents with a carboxylic acid like this, because of acid-base chemistry, we know that there's the minus here would actually just grab this acidic proton right there, and then with the mids, primary and secondary mids, the reaction's not going to happen. You actually can react to Grignard with tertiary amides to get a ketone, but tertiary amides tend to be very sterically hindered, so a lot of times that reaction won't go through, so I'm not going to cover that either. Right, that's a carboxylic acid. So let's go and look. We're also going to cover the formation of Grignards. Just real quick, let's go and look at formation. Okay, so we would start with any alkyl halide like this. You react that with, and it's best just to memorize this, magnesium here, and then diethyl ether, actually, which you'll usually see it written as Et2O, like that. It's just a solvent, and basically you just squish your magnesium in right there. Hopefully, so we know that this alkyl group is actually going to take a minus charge, and this over here is going to kind of take that positive charge, and that's how it's going to react. That's how we're adding, this whatever this alkyl group is to whatever we're reacting it with. And these also, we'll go and write these, they form alcohols. That is the purpose of Grignards, to add carbons to a molecule and you get an alcohol. So let's go and jump right into some reactions. Okay, so let's go and take a look at an aldehyde. Let's do CH3OH like that. And we're going to react that with Grignard. And remember, Grignards must have dilute acid to finish off the alcohol. So basically all that's happening is this with our minus charge is going to attack right there at this carbonyl carbon. It's a very reactive site. And that is going to add, so in this case we'd have our normal CH3 like that. You'd have O would come like that. That would be your molecule there, and then you would have an H from the acid there is going to protonate that there. So you'd get a secondary alcohol with a normal aldehyde like that. Let's actually look at another aldehyde. Let's look at formaldehyde. So you can see how we got this. Hopefully you can visualize. Well, I should have drawn this in one of those CH3s in blue, just so you see that's what's adding. It's just adding right onto there. That's all it is. So with this one, formaldehyde, if we're adding, say, the same Grignard, H3O plus, that's going to add on there. That would now, since there's no other carbons on there, it's going to give us a primary alcohol. It would just look like whoops, sorry. Let me erase that right there. That's all it is. So you just have your one carbon right there would be right here, and then you're just adding this CH3 group on right there. One, you could number it out, 1 like that, 2 right there. And then one of these hydrogens here is going to protonate that alcohol. Oops, CH3 like that. So hopefully that's easy to visualize, just what's going on there. Now let's take a look at a ketone now. It's almost the exact same idea. Well, it really is the exact same idea, but again, let's just use the same Grignard. And I mean, if there was more carbons on here, you would just add more carbons. We'll do one of those next. But I guess here's with the ketone. So now we're reacting this here. Now we would get, let's just draw it like this so you can visualize. That would be our center carbon. Our R's are just like that. We'd get our OH like that, and then our new CH3 would be right there. So hopefully you can see how that's just adding right there. It kicks that up, and then that would go there in step 2. Actually, I really should be writing all of these as this is step 1 and this is step 2. You can't add them in all at once. You'd add your Grignard in first, and then you would add your dilute acid in second to let that mechanism properly execute. But okay, so there's a ketone. Let's go and look at carbon dioxide. Now, what's going to happen when we react carbon dioxide like this with our Grignard reagent? Well, we know that we have that minus charge there, really, with the plus there. It's going to attack here. One of these is going to be pushed off. And the other one's going to be fine. So like I said, we have one that's still a double bond. One has been pushed off, and now it's a negative charge. And then, so we're adding, in this case, we're adding 2 carbons, 1, 2, 1, 2, just like that. And then we know that our O minus would actually get, well, let me write that a little bit cleaner, would get protonated from the dilute acid. So you would be left with the carboxylic acid. So we can't react Grignards with carboxylic acids, but we can use them to form a carboxylic acid. Okay, so let's go and take a look at esters and acyl halides are going to react the same. This is an acyl halide with Grignards. Go ahead and just write out the ester. You're going to need 2 moles of the Grignards to go, because now think, whereas up here, we don't have a good leaving group. You know, H with aldehyde, certainly not a good leaving group, and R group is not a good leaving group either. But now Cl is a good leaving group. OR is a good leaving group again. Let me just draw one big arrow for both of these reactions. We'll just react it with this Grignard like this. We'll go ahead and put 2 moles. And then our dilute acid. So what would happen with this, you're just adding it twice. So in other words, you're going to get this alkyl chain is going to add twice, and you're going to lose the leaving group. So you'd have R like this. With O, we know that O is going to be protonated to H. And now we're going to have, look at that, we just added this twice. 1, 2 carbons, just like that. 1, 2 carbons there, 1, 2 carbons. All we did is add it twice, and then Cl left, because it is a decent leaving group. Now with esters, I'll just draw another arrow so it doesn't get too confusing. Like this. It's the exact same thing, literally. So we would have O, we know the OH is going to get protonated. Then you would have 2, ethanes. Just adding right there onto the side. Now, if you only had one, theoretically, it would stop at a ketone. If you want to picture that, but that reaction actually does not occur, so there's really no need to draw that out. You always, if you're going to react with acyl halide or esters, if you want it to work, you would you got to add 2 moles of your Grignard reagent. Okay, so let's look at epoxides. There we go. There's a good looking epoxide right there. Hopefully we're getting the hang of just visualizing, seeing how those carbons literally just add right on. And, if we have a good leaving group, it is going to leave. If we don't, there's a leaving group's not going to leave, and we just form that alcohol. But let's go ahead and react this with the same Grignard we've been using just to keep things simple. So what's going to happen here? We have our minus charge there, the plus charge here. Let me just do this in red. So where's this going to attack? This is the point of attack there. Over here, this is a little more hindered. It's not going to want to attack there. And this, we're still, it's still that carbon attached to the oxygen there, so it's electrophilic. And so our nucleophile is going to attack right to that point. Now this is all going to stay the same, just like that. So that would be 1, 2, 3, 4. So 1, 2, 3, 4. That bond just broke. There was a bond right there, and that broke. That's all that happened. And then what we're doing is, I'll draw it in a different color here. We're just adding our 1, 2. 1, 2 more carbons that we added with our Grignard. Oh, and I forgot. And we're going to protonate the oxygen ultimately. So again, it's the exact same as the others. It's just breaking apart this epoxide. I think this epoxide, there's a lot of tension in between all these bonds here. It's like spring-loaded. Those bonds want to break. It's not very stable. So this nucleophile here, the Grignard, is going to break that and just add on right to that electrophilic site right there. So hopefully that helps with just visualizing what goes on with the Grignards and how we're just adding the carbons to the the carbonyl carbon right there. Just that's really all that's happening.